Now very often when I buy chemicals in jugs, they'll give you the percentage concentration on the side of the jug, and you'll need to compute the molarity from that. For example, if you buy concentrated sulfuric acid in a 2-liter bottle, they will tell you on the side of the bottle this is 98.3% WW H2SO4. That'll be the concentration stamped on the side. And you'd like to turn that into a molarity of H2SO4. How would you do something like that? Well, let's write this down without the percent sign. That'd be step 1. And I'm going to put grams of H2SO4 because I have a weight there. Percent per 100 grams of solution, the concentrated sulfuric acid solution. And I really want to turn this into a molarity. And I'm not going to just write the word molarity here. That's not enough detail for me to do the calculation. I want to write down specifically what the molarity is. So here I'm going to use the definition of molarity. I want to get moles of H2SO4 on top per liter of solution on the bottom. That's the definition of molarity. Now, I really have 2 problems to do here. One is to turn grams of H2SO4 on top into moles. And that one we're a little bit more familiar with. We did that back a while ago. Gram to mole conversions need what? When you're converting grams of something into moles of something, what do you need? You should say whenever you're converting a mass to moles, you need a molar mass. So I need to know the molar mass of sulfuric acid to do this part. And let me see, it's I could add 2 times the hydrogen mass to the sulfur mass to 4 times the oxygen mass. And when I do that, I'm going to get 98.079. That's a 9. Grams of H2SO4 in 1 mole of H2SO4. That'll get that top calculation done for me. And now I need to do something on the bottom too, because I've got grams here, which is mass, and I'm trying to turn it into a volume. What kind of conversion factor do you need to turn grams of something into moles or into a volume of something? You should say whenever you're trying to turn a mass into a volume of the same substance, you need a density. So where do I get the density? Well, in this case, I'm going to look at the side of the jar, and the jug says 1.84 grams of solution in that jug is 1 milliliter of solution. So my roadmap on the bottom can go to milliliters, because that'll connect grams and milliliters, and then I can just turn milliliters into liters. Don't forget that last step or your answer will be off by a factor of 1,000. Alright, so let's do it. We have a complete roadmap here. I'm going to say, I'm going to write down my starting point again. Now it doesn't matter which side I'm going to work on first, whether I do the top part or the bottom part, doesn't matter. Let's do the bottom part first, okay? So if I'm working on the bottom part, what has to go on the top of the next conversion factor? Well, if I've got grams of solution down here and I'm trying to work on that, I want to cancel it out. So I'm going to put that on top. And I look at my first link. It's 1.84. We're just doing a unit conversion at this point. And on the other side I have milliliters of solution. That will get rid of grams of solution. Now I've got milliliters of solution on the bottom. Is that what we want on the bottom? No, I want liters. So I have to do a conversion where I'm going to take milliliters of solution and turn it into liters of solution on the bottom. And 1 milliliter is 10 to the minus 3 liters. All right. And now I'm all done. I'm not going to keep on going. I'm going to cancel out my milliliters of solution. I'm not going to put liters of solution on top and keep on canceling because I'm where I want to be on the bottom part. So don't go further than you need to. So I'm going to work on the top now. It's got grams of H2SO4 on top, and I want to get rid of that. And I want to get moles of H2SO4 on the top. This is where I use my molar mass. Up here. So it'll be 98.079, I guess. And 1 mole. Okay, so now I can pick up my calculator and just key that in like this. Now, before I do that, let's just take a kind of a quick look at about the size that I expect this to be. This is like 98 divided by 98, so it's almost like those cancel out. Not quite, but almost, right? So what's on the bottom here? You got 100 times 10 to the minus 3. That's going to be a tenth. So if you have 1 over a tenth, that's like 10. 10 times 1.8. I should get something like 18. Now, let's pick up the calculator and see if I get something close to that size. See, if I was doing this on a test, I could have just done it just like I just did it. And if it was a multiple choice test, I probably would have picked out the right choice. All right, but let's do the actual calculation here. Let's see, I got 98.3 divided by 100 times 1.84 on top divided by 10 to the minus 3, 1 EE minus 3, divided by 98.079. And I did get pretty close to 18, right? Because there's a times 10 to the 1 there, so don't forget that. Don't just write down 1.844. You have to be very careful when you're doing calculations to consider your power of 10 over there if you've got one. So this would be, let me write it in, 18.44 whatever, 146 moles per liter. I could write that as a capital M here. H2SO4. Okay, well, what about significant figures? You always have to worry about that. What's the weak link in my calculation? This is exact, the 100, but this is approximate. This has 3 figures. The density had 3 figures. This is exact. This had more than 3 figures. So 3 figures is what I'm going to end up with. So I would report my answer that way. 18.4 molar H2SO4 would be the concentration.